Hi, in this video, let's take a look at how to calculate the prices of the bonds with different maturities, different coupon rates, and different spot rates. We're going to assume that the bonds in consideration, they all have the same face value of £1,000. This is only for simplification. You can change this number to your liking. So let's take a look at the first bond. It has 3 years of maturity here, and the coupon rate is going to be 3%, but it has a very different spot rates across the years. So the first spot rate here is the 1 year spot rate, which is 1% here. Okay, and this 2 year spot rate here is going to be 3%, and the 3 year spot rate will be 4%. These are just random picked numbers. You can try to pick your own numbers and try yourself so that you can have ample practices. Okay, so let's just use these numbers and let's try to calculate the price of the bond. So as we know, the present value of any future cash flow is going to be the discounted present values of all the future cash flows. So we need to discount all the cash flows that this bond is going to give us. So the first cash flow would be in 1 year's time, which would be 1,000 times 3. Okay, so we're always assuming, unless other specified, that the coupons will be paid at the end of the year. Okay, so they will be paid annually at the end of the year. So it's not semi-annually or any other payment schedule. Okay, so here we would have our first 30. This is our second 30, and here at the end of year 3, we would get both the third payment of the coupon here and also the face value here, which is the 1,000 here. Okay, so I have 3 cash flows in the future: 30, 30, and 1,030. And let's discount them back to the present. So the first would be 30 divided by 1 plus 1%. And the second would be 30 divided by 1 plus 3% to the power of 2. And the last one would be 1,030 divided by 1 plus 4% to the power of 3. Okay, so let's just plug the numbers into the calculator, and they should give me the price of £973.65. So that's the price of such a bond, which has a maturity of 3 years and with such a coupon rate and spot rates. Okay, so this is saying if I invest this much into this bond, I'm going to get this, and this as my future payment, and it's fixed because I know at which time point and how much is the bond going to pay me. So the bonds are also called a fixed income instrument or fixed income asset. Okay, so this is one example. Let's take a look at another. So what if I have a coupon rate of 5% now? Okay, so instead of 3% now, I'm just trying to change it to 5%. Okay, and now I have different spot rates as well. So we use the same spot rate for the first 3 years, just like the first one, but we'll extend it to 2 more years. So I have R4 and R5, which is 6%, 7%. Okay, so again, we need to know each of these cash flows. Okay, so let's do it one by one. Since the coupon rate is 5%, so I'm getting 50 here. So divide by 1 plus 1% plus 50 here, 1 plus 3% to the power of 2. Again, 50. So 1 plus 4% to the power of 3. And 50. 1 plus 6% to the power of 4. And last one, always remember the face value added with the coupon here, 1 plus 7% to the power of 5. Okay, again, just plug in the numbers. We should get the answer here, which is £929.32. Okay, so up until now, we're getting very, very different interest rates or spot rates for different maturities here. So what if we have a flat spot rates here, which means R1, R2, R3, R4 are all the same. Okay, so you can always just plug in the numbers just like what we did. Okay, you can calculate the present value of each cash flows year by year, but here, as you can see, there might be a bit of shortcut here. There might be a bit of shortcut because the first at least 3 payments would give you exactly the same amount of cash flow as with all the other coupon paying bonds, right? But the first 3 years, we also have the constant discount rate. So we might be able to use the annuity formula here because that satisfies the assumptions for the annuity formula, okay? So it's just that the 4th year, it seems like it's not going to be able to use that annuity formula because that's 10,060. But what if we just break that 1,060 down into 60 and 1,000? Then we can apply the annuity formula for the last year as well. So why don't we just use the C over R, okay? C over R and 1 minus 1 over 1 plus R, in this case 3%, okay, to the power of 4, and that gives all the present value of the coupons, right? And then don't forget the face value, but this time it's going to be easier because you just have to discount that specific face value back to the present 4 times, which is 3% to the power of 4, and that should give you exactly the same number as if you do the bond pricing manually year by year. Okay, so if you plug in the numbers, this should give you 1.51 here. Okay, so this should provide you another way of looking at the price of the pricing of the bonds. If you have a flat spot rate, which means constant spot rates across the years, then you might be able to use that annuity formula for a shortcut. Okay, but don't forget the last payment, which is the face value. You need to discount it back to the present individually. Okay, so as you can see, the bond prices varies with the coupon rates, with the spot rates here. Okay, so let's put a generalized universal formula for the bond price. The price of a bond is always going to be the summation of all the cash flows, okay, at time t divided by 1 plus RT to the power of t. Okay, so RT here could be different depending on different spot rates. It could be constant, it could be increasing, or anything that's been given to you. Okay, and the cash flows, remember, they're always going to be your coupon rates, and be reminded of the last payment, which is your last coupon added with your face value. Okay, so as long as it's coupon paying, if it's a 0 coupon bond, then it's going to be very easy, just the face value divided by the 1 plus RT to the power of t, and t will be your maturity here. Okay, I'll see you in the next video.